Today's video is going to be on adding and subtracting fractions with different denominators. Let's have a look at our first question, 2/3 plus 3/4. Something that we notice a lot of students doing is they will see the addition sign. Let me just get my pen working. And they will quite happily add the numerators and they will add the denominators, and that is not the best idea. I want you to pause your video now and have a think as to why does this not work. So maybe you know it doesn't work, and I want you to think about why doesn't it work, and then you can unpause the video and compare your thoughts with my thoughts that are about to come. If we look at this first fraction, 2/3, that means the whole has been broken into 3 equal size parts. Sorry about my diagram, it's a bit dodgy with my stylus. And we want 2 of the 3 pieces. If I look at my second diagram, I've got 4 equal parts. My whole has been divided into 4 equal parts. We're going to break it into 4 pieces. And we want 3, as the numerator tells me, that we've got 3 of the 4 pieces. And if I look at that shaded region, we can see it's already bigger than a whole. I've got more than a half shaded in this first circle here. And I've got more than a half shaded in this first circle, in this second circle. So my answer has to be greater than a whole. But if you look at the answer you get when you add the numerators and you add the denominators, it's 5/7. 5/7 is less than 7/7, and 7/7 is a whole. So clearly, this does not work. A big no. So what we want to do is work out, well, what do we do instead? When you're adding and subtracting fractions, we can't add the pieces together of my whole, sorry, I'm going to get my pen going, unless the pieces are the same size. And the pieces won't be the same size unless my denominators are the same. If we have a whole divided into 3 equal parts and then another whole divided into 4 equal parts, those pieces will be different. So to make the pieces the same, we need to form what is called a common denominator. And a common denominator is the lowest common multiple of the 2 denominators that you have. So hopefully, if your arithmetic is good, you can think about 3 and 4 and think, well, I know that the lowest common multiple of 3 and 4 is the number 12. Okay? If you didn't know that, you can always make a list. And you can list your multiples and see and notice when a common one appears. So the multiples of 3, we start with 3, and we've got 6, 9, 12, 15, and with 4, we've got 4, then 8, 12, and there's your common multiple there. So we want ideally the lowest one. A lot of students will think, let's take 3 and 4 and multiply them, and that will work, but it won't always work. Sometimes you'll end up with a much larger number. So I'd advise you to think about it first. When we form a common denominator, we've now changed the numerators. The numerators have gone from 3 to 12 and also from 4 to 12, and that means you're going to need to change your numerators as well. So to go from 3 to 12, what we've done is we've times by 4. So what we're going to do is we need to do the same thing to the numerator as well. If you times the denominator by 4, you need to times the numerator by 4. 4 times 2 gives me a new numerator of 8. For the second fraction to go from 4 to 12, we've times by 3. So let's do the same to the numerator, and 3 times 3 is 9. Then I noticed that I've got a whole that has been divided into 12 pieces, 12ths, and I've got 8 12ths, and then secondly I've got 9 12ths, and I want to add them together. Now that I've got equal size pieces, 8 12ths plus 9 12ths will give me a total of 17 12ths. We're talking about 12ths this whole time. I've got 17 12ths, and so that is why we don't add the denominators in this case. But we are able to add the numerators now that we have equal denominators. We're left with an improper fraction, and if we want, we can change it to a mixed fraction. 12 goes into 17 once, leaving a remainder of 5 over 12. Let's have a look at another example. In this example, we've got 12. Let me just get my pen back again. We've got a denominator of 12 and a denominator of 20. And this is where it's not a great idea to multiply your denominators. If you multiply 12 and 20, you're going to get 240, which is much bigger than it needs to be. So let's have a think about what the common denominators would be. So we've got 12, we've got 20. Let's list the multiples. So we've got 12 as the first multiple, then 24, 36 is next, 48, 60, 72. And we've got for 20, 20, 40, 60. You might stop as soon as you say, oh, I know 60 is a multiple of 20. So you can stop as soon as you notice a common multiple. And there we get 60, a much smaller denominator if we don't multiply the denominators. So be careful not to necessarily always multiply the denominators. So we've changed the denominators to 60. So to go from 12 to 60, we times by 5, and that means we'll do the same to the numerator. 5 5s are 25. To go from 20 to 60, we times by 3. We want to do the same to the numerator, and 3 3s are 9. Then I can subtract, in this case, the numerators because I've got 60ths. I've got equal sized pieces in both fractions. So 25 60ths minus 9 60ths. Well, 25 minus 9 is 16 over 60. Excuse me. And then we can always check whether you need to reduce that fraction. So in this case, we can see the numerator and the denominator are even. So we really should divide by 2. If there's a bigger number, actually we can divide by more than 2. We can divide by 4. So I'll change that. Divide by 4. Divide by 4. 16 divided by 4 is 4. 60 divided by, let's just fix that divide sign, divided by 4 is 15. So we end up with 4/15. Just a few reminders with adding and subtracting fractions. Please work down the page, not across. Okay, so if you look at the previous page, I've worked down the page. Down. Okay, and also I've started every line with an equal sign. Okay, just makes your solution read much better. And take time to find the lowest common denominator instead of just multiplying. So for example, in this first example here, we've got 7 and 4, and yes, multiplying works well. 28 is the lowest common multiple, but in this second example, we've got 6, we've got 3, 6 3s are 18. I don't need to use 18 because the lowest common multiple of 6 and 3 is actually 6. Okay. For this last example, if I multiply 15 and 3, I get 45. But the lowest common multiple of 15 and 3 is actually 15. So the smaller the denominator, the easier your numbers are when it comes to multiplying. So try to make sure you think about the lowest common denominator rather than just multiplying straight away.